Thank you very much, the sages, Dr. Morales, Dr. Pugh, for the privilege of speaking to everybody today. I apologize that I cannot be there in person, but it is my privilege to take this opportunity in the AI session to announce an exciting new initiative that is coming to SAGES, the Critical View of Safety Challenge. Now, these are my disclosures. Now, challenges have a long history in computer science, and perhaps most relevant to start our discussion today is an introduction to the Imagenet Large-Scale Visual Recognition Challenge. Imagenet is a database of over 14 million images. They're divided into categories and they contain information such as what objects or items are in that image, as well as some basic localization information, such as bounding boxes that demonstrate where those objects or images may be. The challenge is a competition that invites teams or individuals from around the world to do their best and create algorithmic approaches to optimizing the identification of different concepts within this database. And this database has been generated over the course of the last decade plus, actually almost going on a decade and a half, after the initial work by Dr. Fei-Fei Li, who was originally at Princeton and is now at Stanford, worked together with other computer scientists and researchers and recruited annotators via crowd work to annotate many of these images that are gathered from publicly available images on the internet. This challenge structure, the idea of having a competition to have teams compete to get the best performance, has really been quite effective in pushing the boundaries of the field. Starting in 2010 here on this graph, you can see such a wide distribution of the teams in terms of performance. I mean, if you look at some of these performances, you have teams that varied from 30% error all the way up to 80% error in identifying images within the database. And each year, that variability has decreased as teams start to converge on better and better performance. But I think 2012 was probably the landmark year in this competition and in the sort of challenge sphere overall for image recognition in particular. And 2012 was the debut of a network or algorithmic approach known as AlexNet from the University of Toronto. It was a convolutional neural network approach that used deep learning that leveraged graphical processing units, or GPUs, to achieve identification results with an error rate 10 points lower than the competition. And it's not just a competition from prior years, it was a competition in that year as well. And since the debut of AlexNet, which is really sort of the most recent sort of spark that pushed deep learning into the daily consciousness of not just these types of computer science research, but almost of like the everyday environment that we live in. If you think about all the press that's generated by deep learning. And you've seen year after year additional improvements in these algorithms to yield better and better performance. In fact, if you look at 2015, it's sort of crazy because 6 years ago, that was when an algorithm beat humans in identifying these images. Now, let's be fair though. Many of these crowd annotators that annotate these data sets, they're trying to move through images as quickly as possible because their compensation is based on the volume and speed with which they do these annotations. And so mistakes are bound to be made. And I think this highlights the importance of ensuring high quality annotations for data. You don't want to train your algorithms on the wrong thing. Also, identifying dogs, cats, apples, oranges, that's a little bit different than trying to identify something complex like surgical anatomy. That's not to say that the only challenges that exist are with sort of simple images that are available on the internet. The NFL, for example, has a current challenge going on right now that invites teams to try to identify helmet-to-helmet contact between two players and to specifically identify the identity of those players by identifying their jersey number, and with the goal of trying to win up to $100,000 in prize money. Medicine is also no stranger to the challenge approach. The Radiological Society of North America, or RSNA, has held multiple challenges over the years to invite teams to identify different structures in things like X-rays or axial images like MRI or CT scan. And here you see an example of the type of leaderboard that's generated and the team members that might be involved in each of these teams and what types of scores they're getting. So teams basically are able to access some training data, and then they're able to submit their code to be calculated or run against the test data set, which is not part of the training data set. And that is how the score is calculated, and then the leaderboard is constructed. And this leaderboard is sort of living in real time based on the timeline set by the challenge. And you can see a lot of movement as these teams improve their approaches or as teams consolidate to try to address weaknesses in their approaches. Surgery is also no stranger to these challenges either. The research group CAMA at IHU in Strasbourg has been organizing challenges with the Medical Image Computing and Computer Assisted Intervention Society, also known as MICAI, for several years. And they've released perhaps the most famous surgical data set in computer vision, Colic 80, as part of these MICAI challenges. In fact, this year, they're organizing the Action Triplet Challenge, as you can see here, the idea of trying to combine information about a tool, an organ, and an action to try to better identify events that happen in the course of an operation. And they're also hosting Clinic AI, which is the first ever joint clinician engineering workshop at MICAI. So it's really a great privilege to have the opportunity to announce that the SAGES AI Task Force is going to be working in conjunction with IHU Strasbourg and Massachusetts General Hospital to organize a challenge to identify the critical view of safety in laparoscopic cholecystectomy. And the hope of this challenge is to really bring together the world in trying to solve the problem of identifying the critical view of safety in some sort of automated way. Now, why do we think that the AI task force can take 2021 as a starting point for such a challenge? Well, last year, just before the pandemic, and this was taken in February of 2020, the SAGES AI Task Force convened a consensus group of 60 participants from 8 countries, 20 universities, and 10 companies. And what resulted over the course of 4 months, starting from 2019 into early 2020, was a consensus set of recommendations that was recently published in Surgical Endoscopy as an official statement backed by SAGES on how to perform annotations of surgical video for the purposes of machine learning. And the critical view of safety is sort of the next step in that progression from taking the basic structure of how do you do annotations in a reliable and a consistent manner, and how do you apply it to actual surgical data in a way that can be used at scale. And so the goal of the CVS challenge is to try to release 1,000 annotated videos of the critical view of safety. And importantly, we are trying to build a balanced, representative, worldwide data set such that the data that is released and trained on for these models can represent as best as we can at this point in time the lived experience of surgeons and patients around the world, and not just try to gather as much data as we can from any source whatsoever. We really want to be intentional about this so that we don't have one institution or another dominating that data set and potentially biasing some of the results that could be achieved. And the goal of this challenge is to build a data set that adheres to the FAIR principles. That is a data set that is findable, that is accessible to researchers around the world, that is interoperable, and in the sense that it can combine with existing data sets like Colic 80, it can be expanded upon, and it can be enriched over time, thus making it reusable and of greater value in solving clinical problems. And in partnership with the expertise that is brought by IHU Strasbourg and by MGH, we're able to put together a workflow where we will invite individuals to register for the challenge, to come together as teams, because I think that this type of challenge is going to be best tackled by interdisciplinary teams that take the expertise of surgeons, such as those of you here at SAGES, and engineers, data scientists, and analysts. There will be a process put in place where you can request access to the training data set. And when the time comes, you'll be able to download that data, train your model, submit that model for validation, and ultimately move on to evaluation, where the results can be computed, the leaderboard updated, and ultimately both cash and travel awards given out to the winners. Now, there are many ways that you can get involved. On the side of sort of setting up the challenge, we are right now inviting data donors. So institutions, departments, surgeons who want to participate by donating their data to the challenge, we would invite you to get in touch with us and submit either full videos of laparoscopic cholecystectomy or a segment around the clipping and cutting of the structures in the critical view of safety. We also invite annotators. We need high quality annotation data to be able to generate this data set. And annotators will undergo training within the SAGES annotation procedures that will be provided by the SAGES AI task force. And you will be asked to complete an annotation of portions of these lap chole videos to try to enrich this data set and try to ensure that the reliability of these annotations is solid enough that we can have confidence in the quality of the data that is released as part of this challenge. For those of you with industry or those of you who want to engage as philanthropic sponsors, we are welcoming sponsors to join our efforts and to help support the efforts that we're engaging in. We, of course, need to be able to pay for the bandwidth and the storage space to enable widespread access. Sponsors will be able to engage with the challenge board, which is made up of individuals from across the world who are both surgeons and engineers. And sponsors will receive recognition in all materials publicizing the challenge, and they'll have, importantly, early access to challenge winners. So if you want to recruit members of these winning teams to your organization, you'll have the ability to do so. And finally, we certainly invite those of you with interest and ability to compete. You'll have access to the training data set. You'll have support from the board members within the challenge and our representatives. You'll be able to participate in the leaderboard should you submit your code for validation. And of course, the thing that interests, I'm sure, many of you, there is prize money at stake, as well as travel to SAGES 2023 in Montreal for an award ceremony and a presentation of your approach in solving the critical view of safety challenge. Now, we already have some early engagement from institutions and individuals from around the world, but we really are looking to expand that footprint. If I can put a pin on every country in this map, that's what I would love to do, because we really want to make sure that this data set is generalizable and that it is really sort of the best balance that we can achieve across all of our experiences as surgeons. So in closing, I invite all of you to get involved. We'll soon be launching the website, cvschallenge.org, within the next week here. And I certainly encourage you to reach out to us at info@cvschallenge.org. That is a live email address as of today. You'll be able to reach out and get some additional information. If you are interested in donating data or in participating as an annotator, please email us and let us know, and we'll be in touch to set things up. If you're looking to compete, keep an eye on the website, and we'll make some additional announcements when we open things up for competition as well. So thank you very much. And I want to thank SAGES for having the vision of putting together such an audacious project and to try to move forward with a future of data-enabled surgery. Thank you.